In this video, we're just going to do a quick review on sequences. Remember, a sequence is simply a pattern of numbers given by some kind of formula. So, for example, this first 3n squared minus 1 over 10n plus 5n squared, if you were actually to list some terms here, let's say you plugged in 0. Well, let's not say you plugged in 0 because then it'd be negative 1 over 0. Let's say you plugged in 1. The first term, if n was equal to 1, would be 2 over 15. And then if you plugged in 2, you'd have 3 times 4 minus 1, so you'd have 11. You'd have 20 plus 20, so you'd have 40. So it's just a pattern of numbers where, you start by plugging in, like this was n equals 1, this was n equals 2, and then you plug in n equals 3, and so on. So that's it. That's all this sequence is. Now, to know if a sequence converges or diverges, all you really need to know is as n goes to infinity. Oh, put the infinity up here. As n goes to infinity, does the sequence go to an actual number? If the answer is yes, then it converges. Okay, if the answer is no, it diverges. So this first one, if you kind of put that mindset in, you say, well, as n goes to infinity, does it have a limit? Well, of course, we've got the same power on top and bottom, so we use the coefficients. You say, oh, it's 3/5, so it's approaching a number. So the answer is yes, it converges, and what does it converge to? It converges to 3/5. So if you continue to go, I did 1 and 2. If you continued to go on, you would get closer and closer to 3/5. Now in this next example, as n goes to infinity, of course you can see right away you're going to get infinity over infinity. But if you use L'Hopital's rule, and you say, well, the derivative of the top is 2e to the 2n, the derivative of the bottom is 1, we take the limit as n goes to infinity, now you get infinity. So the answer is it diverges, and because it diverges, there isn't a number that it's approaching. Up here I notice I shouldn't have said yes, I should have said converges. Okay. Next. This one, the limit as n approaches infinity. Well, this thing's just going to keep toggling between negative 1 and 1, right? It's just going to, if you think about what this sequence would be, it would just be this. Well, to have a limit, you approach one real number. This isn't. This is toggling between two numbers, so this diverges as well. Okay, we have to have a limit of an actual number, not going between multiple numbers. This next one, negative 1 to the n over n. Well, let's list some terms here. If n were 1, you'd have negative 1 over 1. If n were 2, you'd have 1 over 2. If n were 3, you'd have negative 1/3. Okay, and then positive 1/4, negative 1/5, and so on. So it actually will converge, okay, the limit here, because the top is always just going to be positive or negative 1. The bottom is just going to keep getting bigger and bigger and bigger. So it actually is approaching 0. So it converges, and what it converges to is 0. So for a sequence, remember, just a pattern of numbers, it converges if the limit as n goes to infinity of that sequence is a number, and it converges to that number. If the sequence has a limit of infinity, then the sequence is said to diverge.